All right, so this problem is going to be a grams of one thing to grams of another. And what I know when I see grams is that I'm going to need molar mass, and that's going to be of A. I also see that if I've got grams at the other end, that means I'm also going to need the molar mass of B. And I also remember from my other stoichiometry videos that in order to change from one compound to another, I have to have a mole ratio. So those are my basic steps. So what you should do now is pause the video and write down the balanced chemical equation and the problem. You need to make 127 grams of sodium hydroxide. How many grams of Na2O2 is needed? So now that you've done that, I'm going to underline what I'm given, and I'm going to circle what I'm trying to find. That is my mental reminder to myself of what needs to happen. So I'm going to start just a little bit further than the red line, and I'm going to write my 127 grams NaOH. Because I can tell from up here that this is going to be a 3-step picket fence. So now I'm going to take my grams of NaOH and put that on the bottom, just like I always do. And because this is a molar mass, I know that because it's grams. If you have grams on the bottom, you must have 1 mole of the same thing on top. So I'm going to write 1 mole NaOH. The grams then, remember, comes from the periodic table. I use the shape of the triangle to help you remember that. So then I am going to do my scratch work for this right underneath here. So I've got 1 sodium, which is, for my periodic table, 22.99, that's the mass of sodium. Oxygen is 16.00. Remember, we're rounding these to 2 decimal places. So then when I add these up, the molar mass of sodium hydroxide is 40.00 grams. Do you need to show those zeros? Yes, please. Okay. So now grams of NaOH crosses out. But I don't want that, so now I don't want moles of NaOH. So now I'm going to take my moles of NaOH and put that on the bottom. So now I'm trying to find grams of Na2O2, but I cannot put grams of one thing with moles of another. So this is where I'm going to use my mole ratio so that I can get from one thing to another. Remember, these numbers come from the balanced chemical equation. So in front of my Na2O2, I have a 2. In front of my NaOH, I have a 4. That label crosses out. Am I finding moles of Na2O2? No. I'm finding grams. So now I'm going to take this label and put it down here. Can I put grams of Na2O2 with moles? Ah, I can. This is another molar mass. So again, it's the mass of 1 mole. The number of grams comes from the periodic table. So I'm going to do my scratch work for that right up here. So I have Na, there are 2 of them this time, so I'm going to take 2 times the 22.99. So 45.98. For the oxygen, I have 2 of them times 16.00, so that's 32.00. When I add those together, I get 77.98 grams for the Na2O2. So now, all that's left after I cross out my moles of Na2O2 is to put this into my calculator. So let's do that. 127 divided by 40 times 2 divided by 4 times 77.98 equals. And this, I got 123.79 grams of Na2O2. Looking back at my original data, there are 3 sig figs. So my answer also needs 3 significant figures. Keep it, keep it, keep it. That 7 is going to make that 3 round up. So I end up with 124 grams Na2O2.